Hey, super scientists, we're going to do a quick review on stoichiometry, which is balancing chemical equations. So remember, balancing chemical equations applies the law of conservation of matter, and that is sometimes referred to as the law of conservation of mass. So that just says that during chemical reactions or chemical equations, the reactants have to equal the products. So whatever you have on the left side of the arrow, those are your reactants, and then whatever you have on the right side, those are your products. So those two things have to be equal, whether it's by looking at the mass or if it's by looking at the specific number of atoms that is available to you in each of the chemical formulas that is provided. So as we balance chemical equations, we're going to first count how many atoms we have for each of the elements that are provided. We're going to determine what's not equal, and then we have to do the balancing. Then we have to adjust and make sure that each side of the chemical equation correctly represents and applies the law of conservation of matter. For example, in this chemical formula, or these chemical formulas in this chemical formula, we have this coefficient 2 in the front, so that tells us that there are 2 oxygens, and we have a subscript here, 2, that tells us there are 2 oxygens. So that is accurately balanced for the oxygens. And then for the hydrogen here, we have 2 sets of H2. So 2 times 2 is 4, so we have 4 hydrogens. And also 2 times 2 is 4 hydrogens. So this one is accurately reflecting the law of conservation of matter. So your chemical formulas that you see present here, the big number in the front is the coefficient. The small numbers that you see here are the subscripts. Just think of the stem sub means under, so in this case it's lower. And then we have our chemical symbols, the capital letters that we have here that are representing an abbreviation for the element. And then the arrow is our yield sign, which is kind of like the equal sign in math. It's dividing the equation, so this side versus this side. So we're going to do a couple practice real quick. Some people like to use a box to count up the atoms, and that's totally fine. Or you can just count them, or whatever helps you to visualize whether the chemical equation is balanced or not. So the first thing I like to do is draw an arrow, or draw a line through the arrow, and that helps me to see that this side reactants, this side is products. It just helps to literally separate them. So we have 1 iron right here, 1 sulfur, 1 iron, 1 sulfur. For this one, it ends up being balanced already. Another thing that some people like to do is to draw the atoms, draw circles representing the atoms. So if I were going to do that, I would pick 2 symbols. I would pick a symbol for iron, so I might do an open circle. So there's 1 atom of iron. And I might do a closed or shaded circle for sulfur. Or you could use different colors, but that just helps some people to differentiate the different atoms that you have present for each element. So then on this side, I would show that there's 1 atom of each of those as well. So either way you do it, as long as you're able to come to the correct conclusion, is fine. So here is another problem that we're going to do to practice. So here's our reactants, here's our products, and here's our little dividing line between the reactants and the products. So we start out having 2 oxygens. So I'll draw the circles representing that in case you like to count the atoms with circles. So there's 2 oxygens. And then over here, we start with just 1 oxygen. So I'll draw 1 shaded circle for that oxygen. And then on this side, on our reactants, we have 1 hydrogen. So I'm going to use an open circle for hydrogen. And over here, we have 2 hydrogens. So I'll draw 2 open circles for that, 2 hydrogens, 1 hydrogen, and reactant side. So literally that's just what we have without balancing, without doing anything to that chemical equation. So now we've counted the atoms. The next step is that we need to adjust the amounts that we have in order to get it balanced. So we're going to look back at our equation. Remember, you cannot add subscripts. We can never add tiny numbers. You can't take anything away. Like, I can't just mark through this and mark out one of the hydrogens. That's not how it works. You have to balance it with what you have provided to make sure that it accurately satisfies the law of conservation of matter. So the only thing we can add are the coefficients, which are the big numbers in the front. So that's the only thing we can add. So let's take a look at the oxygen. 2 oxygen atoms, 1 oxygen atom over here. So we know we need to get this to be 2. And we've got 1 hydrogen here, 2 hydrogens here. So let's look at the oxygen first because we know this needs to be 2. So what I'm going to do is in the front, I'm going to put a 2. So now that means that I've got 2 sets of H2, which gives us a total of 4 because 2 times 2 is 4, and 2 sets of O, 2 sets of oxygen. So that now gives us 2 oxygens. So I'm going to adjust the counts down here as well for those of you that are counting of the atoms, kind of using a little chart. So we have our 4 hydrogens now, and we have our 2 oxygens now. So now we have accurately reflected what the adding the coefficient has done to the chemical formula. So let's compare our numbers down here again. So we've got 4 hydrogens, only 1 hydrogen, and we have now 2 oxygens because we had the coefficient 2 in the front. So we've got 2 oxygens and 2 oxygens that are represented here. So now we need to adjust the hydrogen here because our oxygens are balanced. So now we need this to be a total of 4 hydrogens. So we are going to put a 4 in the front, and that now means that we have 4 hydrogens. So I'll draw 4 circles to accurately reflect the 4 hydrogen atoms. So now that is balanced, 2 oxygen, 2 oxygen, 4 hydrogen, 4 hydrogen.